Hello and welcome. In this video we're going to be talking about properties of exponents and in particular the product rule. So I tend to call the product rule a base times a base. And that's because later on we'll learn a power rule, and it's similar to this rule and it gets mixed up with it a lot. So I'm going to call this one a base times a base because you're multiplying two bases that are similar with exponents. So the rule says if I'm multiplying these two bases, so they have to be the same, it can't be like an x and a y, it has to be the same variable, I will add the exponents. And the question is why? So let's go ahead and look at this example. I have x squared times x cubed. And I want to break it down to the very basic of what does this mean. So what does it mean to be x squared? Well, x squared means x times x, right? Same thing with x cubed. It means x times x times x. So it times itself 3 times. So now if I was just given this piece here and I hadn't seen that at all, and you were asked to write this exponentially, you would say, well, there's 1, 2, 3, 4, 5 x's being multiplied together. So x to the 5th. So as you can see, what we end up doing is adding the number of x's here to the number of x's there to get x to the 5th. So 2 plus 3 gives us 5. So that's the rule, is when we're multiplying a base times a base, you add the exponents. If they have coefficients, you would multiply the coefficients separately. Let's look at some examples now. I have c to the 4th times c to the 5th. So I know I have 4 c's here and 5 c's there. So altogether, I'm going to have 9 c's. So c to the 9th power. 4 plus 5 is 9. In part B, I have a cubed times a cubed. So again, 3 plus 3 would give me 6. So now I have a to the 6th power. If we have coefficients, like I said, we would multiply those separately. What's happening here is I have 4 next to w squared. So when a number is next to a variable, the operation is multiply. And this is multiply. So really now it says 4 times w squared times 2 times w to the 7th. And multiplication is commutative, meaning I can multiply this in any order I want. So I could rearrange these to make it 4 times 2 times w squared times w to the 7th, and then multiply the coefficients. So 4 times 2 would be 8, and w squared times w to the 7th, again we add those exponents and get w to the 9th. Same thing in the part B example. Inside the first parenthesis, it says 4 times x to the 4th power times y. That whole quantity times -7 times x squared times y to the 6th. Again, this is all multiplication. There's no pluses or minuses, so we can rearrange this. Multiplication is commutative. This is the same thing as saying 4 times a -7 times x to the 4th times x squared. So I'm grouping my coefficients, I'm grouping my x's, and y times y to the 6th. Now I do not necessarily need to see this step on the test or that step on the test, but I'm just letting you know that we can rearrange it because multiplication is commutative, showing I can group the things I want to multiply together. Now, I have 4 times a -7 is -28. X to the 4th times x squared. We add those exponents. 4 plus 2 is 6. Now it's x to the 6th. And y times y to the 6th. Sometimes I get the answer y to the 6th, but I have 1y here and 6 next to it. So overall I have 7 y's, or y to the 7th. It's just when we have a single y, we don't write the 1 exponent. But y to the first power is the same thing as just y. So overall, I have negative 28x to the 6th, y to the 7th. Please try the examples on the right and see how you do. Alright, looking at this example here in the upper right hand corner, x cubed times x to the 4th. I will add 3 plus 4 and get x to the 7th power. Part B, n to the 6th times n squared. 6 plus 2 is 8, n to the 8th power. M to the 5th times m. Again, m is the same thing as m to the 1st power. We just don't write the 1. So 5 plus 1 gives me m to the 6th power. Below that, now we're throwing in some coefficients. Part A says 4 times x to the 5th times 2 times x to the 8th. In between all of those numbers, or the coefficients and the variables, is times. So I can multiply in any order I want. We choose to multiply the coefficients together first. 4 times 2 is 8. Then x to the 5th times x to the 8th. We add those exponents. 5 plus 2 is 13. So 8x to the 13th power. Part B is kind of tricky. A lot of people mess this one up. The reason being, 10 is not a variable. 10 is a number. But 10 is still the base. So I have 3 10s here and 8 10s there. So overall, I have how many 10s? So the base stays the same. Just like x times x, this is still x. 10 to the 3rd times 10 to the 8th is now 10 to the 11th power. Not 100 to the 11th power, because I don't have 11 100s. I have 11 10s. Okay, so that's the difference between being a coefficient without an exponent and a base with an exponent. The base stays the same. Alright, next example. I have 12 times m squared times m to the 8th. So there's only one coefficient, so 12 times 1 is just 12. M squared times m to the 8th. We add them together. 2 plus 8 is 10. So I have m to the 10th power. Alright, the last one here I threw in a fraction, but I have faith in you that you could do it. Put all those whole numbers over 1. And again, this is all multiplication, no add and subtract. I have 2 times b squared times s times 5 times s cubed times negative 3/5 times b. All multiplication. I put those whole numbers over 1 to see if anything will divide out, and sure enough, 5 divided by 5 is 1. Now looking at the rest of the coefficients, I have 2 times 1 times a negative 3 would give me negative 6. Then b squared times b is b cubed, and s times s cubed would be s to the 4th power. And there you have it. So we multiply coefficients and variables separately. If it's a base times a base, we add the exponents, and don't forget the difference between a base and a coefficient.